Okay, so it's 18th of September 2025. I'm Dan Williams. I'm here with Henry Shevlin. And today we're going to be discussing one of the sort of biggest, most consequential debates at the moment concerning AI and the future trajectory and impact of AI. And it's a debate between sort of two conflicting worldviews. Firstly, there is the AI as normal technology worldview, which has been argued for by Arvind Narayanan and Sayash Kapoor, which argues that AI is a normal technology, both in the sense that it's a technology, it's a tool that human beings can and should remain in control of, and in the sense that we can draw on lessons from sort of previous technologies like the internet or electrification to understand the likely future development and impact of AI. And this is often contrasted with what you might call the sort of AI as potentially autonomous, superintelligent alien species perspective, where the idea is AI in the future will develop into a kind of superintelligence that will be so difficult to control and to align with our values and our interests that it's likely to pose a significant threat to the continued survival of the human species. And for like a very clear articulation of that view, you can see the book that's just been published by Eliezer Yudkowsky and Nate Suarez, If Anyone Builds It, Everyone Dies, it being superintelligence there. So Henry and I are going to have a sort of discussion and potentially a bit of a debate about these two perspectives in terms of how we understand them and our evaluations of them. I think I'm a little bit closer to the AI as normal technology view, and I think Henry's a little bit closer to the sort of AI as potential superintelligence view, albeit with lots of nuance, etc., etc. But before we get into any of that, I think it'll be helpful to start by outlining just what these two worldviews are. So, Henry, what's your understanding at a high level of the AI as normal technology perspective?
Right. So thanks. Great to be back on the show, Dan. So I think the normal technology framing is liable to misinterpretation, not due to anything that the authors necessarily do, but it is an interesting choice of word, normal technology, because they're very clear, like in the first paragraph of the article, that, I'll actually quote, to view AI as normal is not to understate its impact. Even transformative general purpose technologies such as electricity and the internet are normal in our conception. So I think like in the limit, the normal technology view is basically just a denial of the superintelligence, radically transformative AI view. What I'm less clear on is exactly where AI falls, according to the authors, within sort of the history of previous technological revolutions. So if we think about the most impactful technological revolutions in human history, if I had to pick top three, it would be something like the Industrial Revolution, writing, and the Neolithic Revolution, so the emergence of sedentary agriculture, right? So the question is like, would they count as normal technologies for the authors? Because, I think there's a good case to be made that AI has the potential to be as transformative as, say, the Industrial Revolution. And I didn't get a strong sense from the article that they take themselves to be giving clear arguments that the Industrial Revolution, for example, is a more impactful technology. In fact, some of the examples they give about the sort of the slow diffusion of technology are precisely the kind of things that they use examples from the Industrial Revolution as examples of this. So I think like the limiting, the kind of clear, I guess I always get Mott and Bailey confused, right? But like the more defensible end of their argument is like, the final redoubt is just that like, this is not going to lead to recursive self-improving AI systems of a kind that will cause X risk, right? I think that's the kind of absolute bastion of their argument. And then there's lots of other stuff that sort of, and this is where I'm really sympathetic to the paper that suggests that AI's impacts will be bottlenecked by a whole bunch of factors, ranging from regulatory factors to issues with adoption and diffusion, issues with speed of training. They give driverless cars as an example of something that took a long time to really get going, and also limitations on training data, as well as just general kind of crowding and herding behavior in science. That means that, just because a new paradigm comes along doesn't mean that everyone leaps to it straight away. They talk about the longevity of transformer models as an example of sort of how this works. And those are all really good points, I think. But here's the thing. It's not clear to me that any of those things are necessarily good arguments against the Bastian view, right? I think it's
Hmm.
entirely possible that 6-7 years from now, I'm not saying over balance of probability, right? But I think it's entirely possible that AI adoption will be slow, and then suddenly, even without massive penetration of AI into industry and business, right, we'll see an incredibly dangerous technological breakthrough that could lead to fairly fast takeoff of X risk, right? So I think those two issues can come apart, right? There's definitely a world in which superintelligence becomes dangerous precisely because it becomes integrated in every aspect of human life and every aspect of business and so forth. But there's another world in which, yeah, AI adoption happens slowly, but then some really dangerous product or prototype gets built at a model at a lab and diffuses very quickly. So I think Gwern has a great example of this. I think it's called something like, so it looks like you're trying to take over the world, that imagines a pretty fast takeoff scenario with a model exfiltrating itself from servers at a big tech company and then rapidly colonizing the global internet and so forth. So I actually think they've got great arguments for sort of thinking about, why adoption may not be as fast as some people think, but I don't think that necessarily cuts to the core of why superintelligence threats couldn't cause X risk.
Okay, so let me sort of repeat some of that back to you, and then hopefully that will help us sort of clarify what they're aiming to establish with their perspective. So you're right. I think part of it is just a rejection of a very common way of thinking about AI, which, as I mentioned, has recently been articulated in this book by Eliezer Yudkowsky and Nate Suarez, but you find it sort of all over the place. It's a very influential view that says basically we will build a super intelligent system or set of systems. This might happen incredibly quickly because of a process of recursive self-improvement, whereby we build AI systems that get involved in the process of research and development, which means that they can sort of iteratively improve AI systems very, very rapidly. And that once you've got a super intelligent system, it's going to pose a significant threat to the continued survival of the human species. So they're opposed to that perspective. And so one way of understanding AI as normal technology is just, we don't agree with that. That would be a kind of negative reading of the framework, of the worldview. But I take it they want to say, no, it's not just the denial of that perspective. It's a coherent alternative. And I think there your point about how, look, according to them, AI can be normal, but nevertheless radically transformative on the scale of, say, the Neolithic Revolution or the Industrial Revolution is important. Sorry, it can be sort of similar in how transformative it is to those previous technological revolutions while still being quote unquote normal. And my understanding is part of what they want to say there is, if you look at all previous technological transformations of society, even when you're dealing with those like really radical technological revolutions, one of the lessons that you can draw is there are many factors that mediate between the sort of raw capabilities associated with the technology and its widespread adoption and use throughout the economy and throughout society. And so you can't merely look at the capabilities of the technology itself and draw the lesson that, wow, this is going to really rapidly transform society. You have to look at all of these different forms of bottlenecks, sort of institutional inertia, friction, all of these things that stand in between those two phenomena, the raw capabilities of the system and the sort of widespread adoption and use of those technologies in society. That's a lesson that they think you can draw from previous technologies. And they're saying we can apply that lesson to the future development of AI. It sounds like you're quite sympathetic to that, but then I do think that is a very different vision of AI and the future. And it is a sort of sense in which they're drawing lessons from previous technologies, which is very, very different substantively to the sort of AI as potential superintelligence view. Is that how you're seeing things, or if I misunderstood?
Yeah, no, okay. I think you're right that there is that very clear positive program, and I'm very sympathetic to it. So they give, the example from one of my favorite articles, the dynamo and the computer, the fact that you had widespread diffusion of electricity as a technology in the late 19th century, but it took a really long time and massive redesign of factories, for example, away from a single sort of steam-powered drivetrain that all the machines on a given factory floor would operate from, to electrification. That took a really long time for a whole bunch of interesting reasons. So I think this is really good stuff. I'm just not sure how it connects to superintelligence concerns,
Hmm.
except in the kind of very contingent fact that very often when you hear sort of some of the more breathless hype from Silicon Valley and from big tech in particular, these two ideas get bundled together, right? We hear
Right.
both AI is going to rapidly transform the global economy in the next 3 or 4 years. And,
Hmm.
we'll see mass unemployment as a result. Oh, and also, so if this continues, it could cause X risk. But I do think those two things can come apart, right? It's not
Right. Right.
necessarily the case that a prerequisite towards a rogue superintelligence killing everyone is first that, we experience mass technological unemployment first. So even though the two things are packaged together, I think they're fully logically separable, and I think plausibly separable theses.
Yeah, that's interesting. I mean, I suppose one of the articles that came out roughly at the same time as the AI as normal technology was AI 2027, which was written by Scott Alexander and a number of other people. And that really does depict this sort of really rapid, radical transformation of society and the economy. And at least in one of what they think of as a potentially likely scenario that they depict, the extinction of the human race. So in as much as this AI as normal technology view is saying, no, you should expect the process of technological diffusion throughout the economy to be slow, it is rejecting that specific view. But as I understand your point, you're saying, well, it could be the case that everything they're saying about sort of the slowness and all of the frictions and all of the forms of inertia, which will sort of slow down the diffusion of this technology throughout the economy, that could all be true. But at the same time, the end point of that is going to be super intelligent AI systems that will radically transform society. I suppose then one question that's sort of worth thinking about is, suppose you adopt the kind of AI 2027 perspective and you think, actually, no, this view about drawing lessons from previous technologies and applying it to AI is wrong. Suppose you accept that kind of perspective. What would you criticize about the AI as normal technology perspective? Because I take it like the alternative view is AI is profoundly abnormal, it's sui generis, and so you can't merely look at previous technologies and their slow rollout throughout the society and throughout the economy to draw conclusions about AI.
Yeah, really interesting. So I think, as I said, there are these two quite different angles. So, sorry, just to get clear on the question, are you asking, what would I say from the AI 2027 perspective about the kind of slowness of diffusion argument or the X risk argument?
Let's postpone consideration of the X risk argument, because I think that raises a whole set of, that's the existential risk argument. I think that raises a whole set of sort of interesting additional questions. I mean, I was just thinking the AI as normal technology perspective, I think what gives it bite and the reason why it's a kind of positive, substantive vision is it says AI might be genuinely transformative, but it's normal in the sense that we can look at general features of previous technologies and the processes through which they've been rolled out and they've diffused throughout the economy. We can look at those previous technologies and that sort of pattern of slow diffusion and apply it to AI. So that even if AI is radically transformative, nevertheless, it's close enough to these previous technologies that that lesson will still obtain. Whereas I think those people who are really skeptical of the AI as normal technology perspective, they think AI is profoundly abnormal, it's sufficiently sui generis that you definitely can't look at previous technologies, whether it's electrification, whether it's the internet, whether it's the steam engine, whatever it might be, and draw lessons from those to the application of AI. And that might, I think, be relevant to this question about sort of how closely the AI as normal technology perspective is linked to this issue of slow diffusion.
Yeah, okay, that's really helpful. So I think there are obviously some questions about AI impact where previous technologies are massively useful. So, for example, if we're talking about the uptake of AI of generative AI tools, current generative AI tools by business, I
Hmm.
think we have a huge amount to learn from sort of the history of adoption of internet platforms, internet tools in business, as well as broader technologies like electrification. That said, I also think just conceptually, AI is quite different from
Hmm.
previous kinds of tools. And whilst that difference may not manifest right now in questions like speed of industry adoption, I think we are building a fundamentally different kind of thing. Explicitly, many labs do say AGI is the goal. And I think AGI as a goal is just a different kind of category of technology, insofar as we're talking about building fully autonomous intelligent systems able to not just sort of assist humans in work, but potentially replace humans in work altogether,
Mm,
and potentially our species. I think for something like that, maybe rather than looking at the internet, electrification, thinking about things like the emergence of writing, which I think there's a good case to be made that writing, or more broadly just sort of encoding information in artifacts, really changes the kind of being that we were. It really changes the long-term possibility space of human civilization. AI potentially takes that even further, but I think that's one reason I think it's interesting to ask, is the evolution of writing just a normal technology? Because it seems to me that really does change what it means to be human, right? Because when you can
yeah.
tap into the collected knowledge, not just of, what your grandparents remember their grandparents telling them, but like actual hard records from thousands of years ago, that is a real game changer, I think, yeah, for the possibilities of human civilization. And of course, doing any kind of large scale scientific research, large scale commerce, with hundreds of thousands of people, is only possible once you have things like writing. So
Yeah.
that I think is getting us towards thinking about the kind of potential scale of impacts of AI. I mean, one analogy that I think we discussed in our last podcast is, biological evolution, the shift from chimpanzees to humans, right? The fact that we are about to introduce, or may soon introduce, beings to our world that have goals, agency, autonomy, and are also just smarter than us. And whilst I think there's a huge amount of uncertainty and inevitable speculation involved in thinking about what that looks like, I think some pretty extreme scenarios do potentially follow from that kind of scenario, which I think it's very hard to think of, how could the internet kill everybody? How could electricity kill everybody? It's quite straightforward to come up with totally speculative, but not incoherent scenarios where AI does kill everybody.
Yeah. Okay. I'm very skeptical actually of those sort of species analogies when people are thinking about future AI systems, and that might be one respect in which I am more sympathetic to the AI as normal technology view. I mean, maybe there's a helpful distinction here between the sort of size or the magnitude of the impact, where I think the AI as normal technology view can say, yes, this could be radically transformative. It could change what it means to be human in much the same way that other previous technologies have scaffolded and extended human cognition. So they're happy with the idea that you've got this enormous sort of size of the impact, but nevertheless the speed of the transition from how we are now to a potentially radically transformed world is going to be much slower than is often thought, and we should draw that lesson based on an analogy with previous technologies. I think I've heard several arguments from the opposing camp. Maybe two of them are worth discussing briefly. One of them is, and this comes from Scott Alexander, he's got an article called, I think, AI as Profoundly Abnormal Technology. One of the points he makes is, what are you talking about? Diffusion is going to be slow. Already, systems like ChatGPT are being rapidly adopted throughout the society and throughout the economy in all sorts of ways that has no parallel with previous sorts of technologies. Doctors, academics, etc., pundits, journalists, and so on and so forth are already using these technologies, even though they're nowhere near as good and as capable as they potentially will be in a few years. That's one kind of counter argument. And then another kind of counter argument is to say, so AI as normal technology view, many of the forms of friction that they're pointing at are things like, well, concerns about safety, concerns about the reputational hazards of using these technologies in certain kinds of contexts. That's going to slow down adoption. But the point that Alexander makes is the speed with which these things are going to diffuse throughout the economy will be driven by the most aggressive actors who are much less constrained by these sorts of things. So if you're thinking about the US military, they're going to be, deeply concerned with getting their hands on any kind of technology which can give them a competitive advantage, as you would expect also for, let's say, the Chinese military as well. And those are two interesting arguments, I think, that really do put pressure on the idea that we can draw straightforward lessons from previous technologies to AI. Have you got any sort of thoughts about those counter arguments?
Yeah, no, that thank you for crystallizing those. Right. So I think we've got sort of three candidate theses. One of them is AI is there a reasonable chance that it causes X risk, that it will mature into superintelligence? The second is how widespread will and how fast will adoption be? And the third, I think we can sort of separate out from those two, which is the question you were just addressing, is how quickly should we expect AI to achieve superintelligence from our current starting point? And I think those are three questions worth distinguishing. So I think the example that Scott Alexander gives, both examples are great. Obviously, in so many domains, we've seen incredibly rapid uptake of generative AI tools. In the original AI's normal technology paper, they sort of emphasized that a lot of people using them only use them for very short periods. I
Right.
think Scott replies that it's hard to infer much from that, right? Maybe they only spend a small amount of time using them, but they use them for very high stakes use cases. And it's just like quick query, quick answer. And I think when we look at sort of the history of technology, what we do see is accelerating trends in adoption as well, right? So you think about how slow sedentary agriculture was to diffuse, how slow writing was to diffuse, farming practices during the various agricultural upheavals we've seen diffuse very slowly, industrial revolution still pretty slow, internet very fast, and generative AI even faster. And obviously there are pretty straightforward explanations for this. A globalized world, highly interconnected societies. If one person starts using generative AI now, they don't need to, other people who aren't using it don't need to wait for missionaries to show up and through masted sailing ships and explain how it works. So I think that's one cautionary lesson about drawing inferences from previous technologies, that things have changed at the adoption level as well.
Right.
So I think that's one important part. And sorry, the second point you made was
I think the second point, that I didn't make, but Scott Alexander, and I think this sort of rival camp makes, is, you can't just look at, as it were, the average person or the average organization or the average institution when it comes to how quickly these technologies might end up getting deployed. You have to look at the most aggressive actors, using actor in the sense in which social scientists talk about actors, agents within society. So central to the sort of AI 2027 scenario forecasting is precisely this idea of a military arms race between the US and China. And there the idea is, well, you shouldn't expect this really sort of, careful, risk-averse adoption of technologies when it comes to those sorts of actors within society, because all of the incentives are pushing them towards using these technologies, which potentially will confer, real strategic advantage on them as quickly, as rapidly as they can. And I think it's noteworthy that in the AI as normal technology essay, from what I remember, they say something like, we're sort of excluding these issues of military arms races from our analysis at present, but we hope to return to them in the future. And I do think that is potentially a weakness of the framework. You might very well think that you can't understand how AI is likely to develop and the very specific risks that AI generates without focusing on something like the military, where potentially it could be very transformative and very risky very quickly. That was my understanding of the Alexander point.
Yeah.
You might have had a different understanding.
No, I think that's quite right. And I also think that we can see, it's a point made in the original paper, to be fair, on AI as normal technology, that arms races are happening simultaneously in multiple areas. So military arms races are one. Arms races between tech companies are another. So I think it was just very striking that, Google was sitting on LLMs, very good LLMs. They have models like Lambda and Palm internally. And then with the launch of ChatGPT, the reaction I got from friends at Google and other companies was, hang on, they just pushed this to product, right? And we could have done this, and we assumed there'd be horrible backlash if we did, because these things aren't necessarily ready for prime time yet. But then the fact that OpenAI sort of got away with it, so to speak, the fact that, people realized, oh yeah, these things hallucinate. You can get them to say terrible things with the right prompting. Basically, the consumer market shrugged and, to varying degrees, learned how to work around these limitations. And of course, the models improved. And I think that's given rise to a kind of push to product mindset that is much more intense now than it was, say, 10 years ago.
Yeah.
And I think, that's a contingent feature of how the current commercial technological world has evolved over the last 2 or 3 years. Yeah, again, sort of in support of sort of Scott Alexander's point, I think we're seeing similar aggressive arms race dynamics between tech companies. I think things are a little bit tricky once we talk about individual sectors. AI in law, AI in medicine, where there's a much more robust regulatory and legal environment. However, I think if you look at other areas, other commercial areas like coding, I think Alexander quotes sort of the insanely high levels of penetration of vibe coding and AI generated code in coding as a career. So I think there are other areas where, we'll see very rapid adoption there too.
I think a really interesting case that in a way illustrates the AI as normal technology perspective, that there's this sort of gap between the raw capabilities of the technology and the extent to which we actually make use of those capabilities within society, would be the educational sector. We're both academics. I think even, current generative AI has the potential to radically transform education in all sorts of ways that are, to put it mildly, not currently being implemented within our most prestigious educational institutions, thanks to all sorts of reasons. There's lots of opposition to it. There's just a kind of slowness of diffusion. There's lots of confusion, suspicion, etc., etc. So I think that's a very clear example where there's this sort of mismatch between the raw capabilities of the technology, what we could in principle achieve based on that technology, and the actual widespread adoption of that technology in ways that realize its full potential. I think there's then just the question, which is to what extent this sort of inertia and these issues with, let's say, the educational sector would generalize to the broader society and the economy. But I think we've covered, I think, that aspect of the debate, which is, how slow should we expect the diffusion of these technologies to be throughout the economy? I think there's another aspect of the AI as normal technology view, which you might think is sort of dissociable from all of this, although maybe there are some connections but between the two. And it concerns this concept of intelligence, right? So I think you've alluded earlier on to this idea that, you might say human beings are smarter than chimpanzees or something like that. And the whole framework of superintelligence says, look, we're going to build systems which are super intelligent. They're much more intelligent than human beings along all relevant dimensions of evaluation. And I think in the AI as normal technology perspective or essay and the perspective that essay articulates, they make a few related points. One of the points that they make, which I think has been made many times before, is that this is in some ways quite a kind of strange and almost pre-scientific use of the concept of intelligence. The idea that a human being is more intelligent than a dog and a dog is more intelligent than a mouse. You might just think the very idea that intelligence here is something that can be sort of situated on a single scale is dubious. And if you're doubtful of that whole framing, that might have lots of knock-on ramifications for how you think about this debate. But they also make another point, which I think has been made elsewhere. And this point I think is really important, which is they draw a distinction between intelligence in the sense of the raw capabilities of a system. So we can think of, Henry, the wetware inside your head, what that enables you to do as an individual, and power, which is the ability of a system to actually manipulate the environment to achieve a given set of goals. And their point is, look, if you're thinking about human agency and human power, it depends on so many things independent of and over and above the kind of raw capabilities of an individual agent. It depends on cultural evolution, the sort of accumulated body of knowledge, of tools, of ideas. It depends on institutions. It depends on collective intelligence. And it also depends on the use of technology. So as we were mentioned, writing is not just a tool that individually intelligent human beings use. It's something which scaffolds and extends the nature of human capability. And I think that's a really interesting point that they make. And I think it does have lots of interesting kind of implications for thinking about AI, because it suggests you can't just say, okay, let's compare an individual human being against a super intelligent AI system, because what a human being can do is not merely a function of what's in that individual human being's head. It's dependent on all sorts of additional factors, including technology. So maybe the next thing we can discuss then is this whole sort of can of worms concerning intelligence. Let's focus on the first of those, the idea that we should be skeptical of this very idea that you can use the term intelligence to say a human being is more intelligent than a chimpanzee, is more intelligent than a dog. What are your thoughts about that kind of debate?
Yeah, so really, really interesting set of questions there. So the first point I should agree with is that I think intelligence is a really murky concept, particularly when applied across species. There are various ways of operationalizing it. in the human case in psychometric contexts, IQ being the most famous kind of psychometric construct here. But I think if we're asking, like, is a golden retriever smarter than a seagull, right? I think we quickly run into sort of conceptual issues, right? How do you weight navigational abilities or the ability to keep track of one's location in varied conditions? How do we weight that against an amazing sense of smell, for example? It's very hard to do so. So there's the famous definition by Legg and Hutter that defines intelligence as the ability to achieve goals across a wide variety of circumstances. But I think it's sort of a gloss for the folk psychological, the everyday notion of intelligence. That's decent and allows us to do some kind of very heuristic comparative work. But I mean, it quickly runs into lots of theoretical questions. So just to give one example, right? Like nematode worms live everywhere, right? They, basically wherever you've got any other kind of living creature, you'll find nematode worms. Does that mean nematode worms are super smart because they can achieve their goals in a wide variety of circumstances? Not really, because they're the same goals. To put it poetically, the world is flat for nematode worms, right? They can basically get by with the same toolkit in different contexts. So that immediately kind of shows the need for precisification or elaboration of these kinds of different goals, of these kind of different notions of intelligence. Likewise, I think there are interesting sort of cognitive science questions here about how modular capacities relate to intelligence. So take, actual bird navigational abilities are more complicated than this, but let's just say, for the sake of example, birds have a navigation module that's completely sort of sealed off from their other kind of capabilities, and it can do great navigation, but it doesn't really interface with other forms of intelligence beyond sort of saying, okay, now keep on flying in the direction you're going. Does that count less in assessing the intelligent capabilities of a system and so forth? So all of that is just to agree that I think our intelligence is not necessarily a helpful or clear concept in every case. I think it's better to talk about capabilities as they do. And this does sort of pull in the second point that you raised, which is that the relationship between capabilities and intelligence is really murky. And it's not just the case that your capabilities scale linearly are purely sort of monocausally determined by your intelligence or kind of raw capability, or there's a gap there. That said, I think it's pretty clear that a large part of why humans are so successful is our intelligence, or our ability to do a whole bunch of cognitive tasks that are beyond the potential of nearest primate relatives. Joe Henrich, who I'm a big fan of, sort of downplays this a bit in his book, The Secret of Our Success. And, I think he points to lots of ways in which chimps are surprisingly smart, but I think he also slightly possibly overstates the case. I think there are certainly clear things that, no matter how much social coordination chimps do, they're probably never going to they just don't have the brains of calculus, for example. And so I think, to sort of respond here, so the first point is intelligence is clearly part of why we're so successful as a species.
Right.
Or our cognitive capabilities are part of why we're so successful as a species. Secondly, just looking at different humans, IQ is not a perfect predictor of life success, and it's still less a predictor of earnings. When you control for everything else, intelligence does generally help you facilitate goals. And humans differ dramatically in intelligence. And again, of course, there's all sorts of caveats and asterisks here, right? If von Neumann was born in a hunter-gatherer society, would that have translated into success? Obviously, intelligence can also come with downsides, like alienation from one's peers, comorbidity with various types of neurodivergence, for example. There's a pretty solid connection, particularly in fields like scientific research, professional success, where intelligence significantly improves people's performance. And of course, humans differ dramatically in this capacity. I guess a final point I'll make.
Well, just on that, sorry to interrupt. I mean, we can turn to that final point. But you said humans differ dramatically in that capacity. And, you might read that as saying, well, there's the capacity of being intelligent. And I do sort of sometimes worry that that's sort of in the background and how people think about this. I mean, you might think, how people perform on IQ tests and, the correlation in their performance across diverse tasks, it's not because there's some underlying capacity of being intelligent, which we can score. It's rather that all sorts of other capacities that we have happen to be correlated with each other, maybe for some reason like, brain health or something like that, not because there's something called being intelligence. There's a whole constellation of abilities that human beings have, and performance across different domains tends to be correlated, but not because there's some underlying thing called being intelligent. I take it that's part of the sort of worry some people have with the loose way of talking concerning intelligence that you sometimes find in this debate. Sorry to interrupt you, but I just wanted
No. I think that it's a very good clarification to throw in there. Yeah. So I don't think you need to believe that there is a unitary natural psychological kind corresponding to intelligence
Right,
in
right,
order for sort of intelligence talk to be useful,
right.
at least in sort of when thinking about humans, right? There's a whole bunch of different capabilities that are broadly correlated. And interestingly, I think they're correlated to a reasonably high degree in LLMs, right? LLMs
Hmm.
that do better in one type of task tend to do better in other types of tasks as well. Again, that doesn't presuppose some kind of underlying unitary foundation, just that, the kind of resources that improve one task improve others. And I think this, again, the trend line is towards increasing performance across diverse baskets of tasks. And that makes these systems more useful. And I think even without sort of invoking, this idea of a unitary conception of intelligence, sort of just extrapolating these trend lines outwards, even using sort of fairly modest assumptions, takes us to the point where the utility of these systems and their ability to influence the world is going to continue increasing in a way that's going to have really quite massive social consequences.
Hmm. Yeah, that's great. So I think that's right. And just to quickly just return to one thing you said, the sort of the comment about Henrich's work and Boyd and Richardson on cultural evolution and dual inheritance theory. I mean, often the framing that they put forward is, what's the secret of human evolutionary success? It's not individual level intelligence. It's the fact that we can engage in social learning and cultural evolution and the sort of accumulation of knowledge and wisdom and tools and so on. And I think it's quite a confused framing for the reason that you pointed out, because really what they're saying is, and I agree with this, that raw computational brain power at the individual level is not sufficient to explain ecological dominance, which is true. But I do think distinctive kinds of human cognitive abilities are necessary to explain. And that's a very, basic philosophical distinction, which I think helps to clarify that whole view. But I think this actually really segues nicely into a discussion of what's really, I think, at the heart of the conflict between this normal technology view and the potential superintelligence view, which is what are the kinds of risks, what are the kinds of dangers that we should be worried about? And to give a slightly sort of cartoonish summary of my understanding of where these two different worldviews sort of identify the specific kinds of failure modes and risks, I think the AI as normal technology view says, look, we should be worried about the misuse of these technologies by human beings and by coalitions and organizations of human beings, acting on either nefarious motivations and goals or just sort of self-serving motivations and goals, which aren't aligned with sort of general social welfare, under capitalist, under specific kinds of bureaucratic capitalist modes of social organization, or under kind of authoritarian or outright totalitarian modes of political organization. So there the risk is human beings using potentially very capable, very powerful AI technology. Whereas the superintelligence perspective, I think people within this sort of area, they're happy to say, yes, those misuse cases are real and we should worry about them. But there's this other thing, which is potentially much more dangerous, which is not the misuse of the technology by, as it were, misaligned human beings. It's misaligned AI systems themselves. That is, once we've built super intelligent AI systems, which they think we're inevitably going to do, and this might happen very, very rapidly due to these processes of recursive self-improvement, we are not going to be able to, that's too strong a way of putting it, actually. We're going to struggle to be able to control these super intelligent AI systems and to align them with our values and our interests and our goals. And that really is a sort of a conflict in terms of how we should understand the risks and dangers associated with these technologies. And I think potentially that is where these questions, which seem like they're quite abstract and academic about the nature of intelligence, become relevant. Maybe I'll walk through how I understand the worries from the superintelligence side, and you can tell me what I'm misunderstanding or what you disagree with. I mean, I think there's sort of different stages to the argument. The first stage says, look, we are going to build super intelligent AI systems relative to some, explication of what superintelligence means. We can say initially systems which are much better than human beings, basically at everything that human beings do. It then says this process of developing super intelligent AI systems it might happen extremely rapidly thanks to this process of recursive self-improvement, where we build smart AI systems which get involved in the process of building smarter and smarter AI systems. And so you get what's sometimes referred to as FOOM, this kind of rapid recursive self-improvement. And then it says, look, once you've got a super intelligent AI system or set of AI systems, it's extremely difficult to control these systems, partly because these systems tend to be quite inscrutable. So even though we in some sense design these systems, because of the nature of state-of-the-art AI, we actually don't have a particularly good understanding of how they work. And partly because even if these systems aren't going to develop outright hostile motivations to human beings as their ultimate objective, most sort of instrumental goals that they're likely to develop on the way of achieving any ultimate objective they might have, even if it seems like it's a benign ultimate objective, are going to be sort of antithetical to human flourishing and survival, because they're going to want to preserve their own survival, they're going to want to acquire power, they're going to want to manipulate the world to their own advantage. And so given that, once we've built these AI systems, these super intelligent AI systems, we're really in trouble. And some people think, we're in trouble, this is a really significant X risk, but maybe if we kind of work on it and we're really careful about it, it will turn out okay. And then there are other people like Eliezer Yudkowsky who think, no, if we build this, given the current state of knowledge, we're screwed. And we can be highly confident that that's the case. That's my understanding of the basic worldview. What are your thoughts about that presentation and about the worldview itself?
Yeah, great framing. I think there's a lot of that framing that I'd agree with. Maybe just a little bit of scaffolding I'd add. So just a simple point, we've already built super intelligent systems in narrow domains, right? You could play,
Right.
according to some predictions, you could play Alpha Zero, you could play it at Go or chess for like 1,000 million years, and you're never going to win a single game against it, right? So in narrow purpose domains, we've shown that you can achieve sort of vastly higher levels of ability on certain types of tasks. And then the question is, as this sort of basket of tasks expands, as AI becomes increasingly general, the associated risks of these general domain capabilities and superintelligence across these domain general capabilities will expand. I think one little caveat is, the superintelligence doesn't need to be better at everything. It just needs to be better at, it needs to be as and or more intelligent than humans across a sufficiently wide range of capabilities that it could cause serious harms. That's one little extra bit of scaffolding. Another little bit of extra scaffolding I'd add is that in addition to sort of recursive self-improvement, there are other reasons you might think superintelligence could have big impacts very fast. So one idea that's sometimes introduced is this idea of a compute overhang. So let's just say we find someone stumbles across the next transformer type models that can do everything transformers can do, except they use an order of magnitude or 2 orders of magnitude less compute to do it at a given performance level. That could unlock massive returns on performance very quickly. If that sounds far-fetched, right, I do sort of go back to kind of the biological anchor of the human brain. We use very little electricity, very comparatively little energy, and obviously a lot of learning, a lot of information. But we are generally intelligent beings, and our general intelligence fits within the volume of a human skull. I think, that obviously doesn't show that silicon-based intelligence could achieve the same level with the same power constraints. I think that's very unlikely. But I think it does sort of show that, in principle, human-level general intelligence is possible with relatively low power requirements within the bounds of a human skull. So, with those caveats in mind, I think it's not crazy to think that in relatively short order, say the next 5 to 10 years, we'll build systems that are super intelligent or sufficiently more capable than human beings across a basket of cognitive domains that allows them to have outsized impact, potentially catastrophic impact, or even existential threat level impact. And to break down sort of what the kind of alignment failure notion that kind of came through in your helpful framing of the issue, worth distinguishing between 2 different kinds of alignment failure. This is not original. This is widely discussed in the AI safety literature. Outer alignment versus inner alignment failures. So outer alignment failures are basically reward misspecification problems. Think of like the classic evil genie type scenarios or the classic paperclip maximizer. We tell the AI to do something. It completely follows our instructions, but follows them in a way we weren't expecting. And this is something you see a lot in RL models, in particular, building games playing agents that have, for example, a task of maximizing their total score in a game. There was a famous case where a games playing agent would kill itself after the first 10 seconds of a level and restart the level because the first 10 seconds were the most dense in terms of points that could be collected. This is kind of deviant or unexpected fulfillment of training conditions, reward functions. And that is sort of the classic alignment failure. The AI is, as far as it's concerned, it's doing exactly what we want, but we got the instructions wrong and it screws up. And as I say, in the case of RL agents, we have lots of examples of this causing very localized problems. I think, interestingly, at least in the case of large language models, this is less worrying than I think it used to be, partly because of the surprising success of RLHF, reinforcement learning through human feedback and fine-tuning. LLMs are spectacularly good at figuring out what your real underlying intentions are and fulfilling them appropriately. After a few beers and I'm asking ChatGPT some barely coherent question that, my wife would struggle to understand, and it's very good at figuring out what I mean. Interestingly, there's also some good research on emergent theory of mind in large language models that I think, they can do a lot of kind of conversational pragmatics, so to speak, to use a fancy term, right? Figuring out what underlying intentions are behind a query. So I think I'm a bit less worried about outer alignment failure than I used to be. By contrast, inner alignment failure is roughly, it's a more messy and complex notion, but roughly the idea is if you're optimizing for any given goal, right? Let's say making paper clips to go with the classic example, systems that are sufficiently optimized to achieve this goal will acquire a bunch of subsidiary goals, right? So this is sometimes known as instrumental convergence.
Right.
For example, if you're trying to maximize the number of paper clips you want to make, well, you probably need a good general knowledge of what's going on in the world in case there are new scientific developments, in case there's some new breakthrough that allows you to make paper clips faster. You probably want to avoid people interfering with your production lines because that can interfere with the number of paper clips you're making. You probably want to acquire a high degree of influence so that opportunities to expand production to other factories and so forth, if they come along, you can leverage them, right? So roughly the idea here is that we should expect to see a whole bunch of what Steve Alejandro called the basic AI drives.
Right.
Sort of kind of fundamental goals emerging instrumentally in the course of training for any other goal. And there was a big debate about this between the likes of Stuart Russell, obviously one of the most widely cited computer scientists in the world, and Jan LeCun, head of AI research at Meta, or former head. It's not quite clear at the moment. And Jan LeCun basically said to Stuart Russell, look, this is hopelessly anthropomorphic. Yes, humans tend to have desires like power seeking, but we shouldn't expect them to arise in AI systems. That's just anthropomorphism. Well, two responses to that. The first is that, well, if you buy instrumental convergence, then sort of these are things you'd expect to see emergent in any goal-driven system. But even if you're unconvinced by that, the current trend over the last 5 years has been towards increasingly human-like AI systems, or what I've called anthropomimetic AI systems that are human-like in many ways, partly because they're trained on human vast text, corpuses of human text, partly because they're fine-tuned to exhibit certain kinds of human qualities. So even if you think it's anthropomorphic to attribute these kinds of ulterior motives, or not ulterior, that's not quite right, secondary emergent goals.
Instrumental motives, yeah.
Exactly. Even if you think that's not realistic for just kind of pure reinforcement learning agents, when you're specifically optimizing models to be human-like in many respects, you're probably going to see these qualities emerging. So my favorite example here is the case in safety testing with Claude. To simplify the story slightly, basically, that Claude was told it was going to be switched off. And an engineer mentioned to Claude that he was having an extramarital affair and please don't tell anyone. And Claude attempted to engage, tried to blackmail him to avoid being turned off. Now, the story's a bit more complicated than that, but it's basically a kind of human-like Machiavellianism or motive that looks a lot like instrumental convergence.
Yeah, that's really interesting. Okay, so there's loads of stuff there and there's loads of stuff in what I said. Maybe just to provide some sort of structure to the rest of our conversation. And just to lay my cards on the table, and I said this in our first conversation, I'm very, very skeptical of these existential risk arguments when it comes to misalignment of the AI systems themselves. I do think there are issues to do with existential risk when it comes to human misuse of these systems or use of these systems in high stakes domains, like, for example, military conflict. But at the moment at least, fairly skeptical of the kind of Yudkowsky view that it's the systems themselves, these superintelligent, potentially autonomous superintelligent agents that pose the risk. And I think one useful framing that sort of subsumes many of the things that you've just said, but it will enable us to go sort of point by point, will be to first focus on this question of capability. Would an AI system, let's supposing that it quote unquote wanted to wipe out all of humanity, be capable of doing so? And then the second question would be, is there any reason to think that AI systems, as they're going to exist in the future, would, quote unquote, want to wipe out all of humanity? It seems like those questions they're connected in some sense, because presumably a system would only want to do something if it thought it had the capability of being able to pull it off. But they're also, it seems to me, separate questions, and they're worth sort of engaging separately. On the capability question, here is where I think our discussion about the nature of intelligence becomes relevant. Because when we were framing things, and in your discussion of superintelligence is often contrasted with human intelligence. The idea is these systems are super intelligent in the sense that they're much, much more intelligent than human beings, right? Across all relevant domains of evaluation, or at least across most of them that are relevant to conferring a strategic advantage. And here I think the AI as normal technology point about intelligence becomes relevant because, well, what are we comparing such a system to? Are we comparing a AI system against me, Dan, an individual, right? Or are we comparing the AI system to human beings as they actually exist in the world with their power, which is massively owed not just to individual brain power, but to complex, collective, distributed intelligence, thanks to institutions, and also, really importantly, thanks to the use of technology itself, including AI systems. And then I think the idea that there's going to be this really decisive strategic advantage of one of these systems relative to human beings becomes a little bit less plausible, because it's not about an AI system which is sort of incredibly competent merely as a consequence of its own capabilities. There's a question about its capabilities and its power, which will depend on things independent of those capabilities, being compared to human beings with all of the extra neural, the kind of outside of the head stuff that actually gives us power and competence. That's where I think that aspect of the discussion becomes relevant. And that's one reason why, even though most of my skepticism concerns the issue of motivation, even if I set that aside, I'm a little bit skeptical of the idea that these super intelligent systems that are being hypothesized would actually be capable of wiping out all of humanity. What do you think?
Brilliant. Yeah. Okay. So let me start by asking you a question, right? So agreeing that our capabilities as a species rest on this massive assemblage of sort of social cognitive prostheses, everything from like physical hardware to relationships to institutions. Which of these, if any, do you think a sufficiently smart AI system or sufficiently capable AI system couldn't use? It seems to me we've created all this amazing basket of tools, but I don't see any reason why an AI couldn't use them just as, if not more effectively than us.
That's interesting. Well, for one thing, it's an AI system where there's an enormous amount of suspicion directed towards these systems, skepticism. I think people's basic attitude is not one of trust for the most part. So I think already it's going to sort of face an uphill struggle. Secondly, in terms of our capacity to sort of, get access to so many of these features of human abilities, a lot of it is not merely a consequence of our sort of raw computational power, right? It's to do with social status, the alliances that we form, all of these things which aren't strictly to do with raw computational power, but have to do with the fact that we're human animals interacting with other human animals. And then thirdly, there's this issue which I think also constantly arises in this sort of question of the conflict between these two worldviews, which is, the future of AI and how it's going to unfold is going to be shaped by human choice to a substantial degree. And it seems like precisely because of these, questions and potential dangers concerning risk, we should, and we have the ability to be very, very careful in terms of the power that we give these systems, considered independently of their raw capabilities. That's my immediate reaction.
Okay, not to be too snarky, but like when the misaligned superintelligence comes knocking on your door, it's not going to be wearing a badge saying, "Hi, I'm a misaligned superintelligence," right?
Right,
To
right.
give like a really simple, trivial example, imagine, I mean, how many of your Twitter followers are bots, right? I don't know in my case, right? Like I've got lots
0%
of
of them in my case.
0%, obviously, right? So, imagine someone comes along online and starts regularly engaging with your tweets, right? They've got this classic anime avatar, whatever, right? They make insightful points. Maybe they become a lifetime subscriber of your Substack. I don't know if you have like a donation system, or they start giving you big tips. They
Right.
really engage with your followers. They hook you up with other prominent people online. They say, here's a connection, right? And they say, would you mind writing a blog post on this sometime? I'd really interested to hear your thoughts on such and such. And over time, they develop like a patron-client relationship, right? And it could be an artificial superintelligence doing this, right? More broadly, I think the point is that in a world in which so much communication is electronically mediated, the AI is not going to have to show up in a blue blazer saying, "Hi, could you do this for me?" Right. So I think a huge portion of our tools, maybe not quite all, don't require any kind of face-to-face contact, and a sufficiently sort of cognitively sophisticated AI system could do a huge amount. We saw this famous example in the Sparks of AGI paper back when GPT-4 was released, of an AI instructed to get through a captcha, but it asked I forget which particular service it was, but basically a service where you can get people to do things for you, asked a human to solve the captcha for it. When asked why, it said, I'm partially sighted, so I need some help with this. So in general, I see most of the kind of tools of influence, economics, power as being accessible to an AI system without it needing to sort of declare its hand there.
Well, there's going to be so much opposition to that kind of scenario unfolding. And I find even with that scenario, I mean, it seems to me so many things would need to obtain for that scenario, in my own case, to unfold, which is sort of individually quite unlikely, the combination of which seems very, very unlikely. I mean, the first thing you said is I'm meeting this sort of, person I don't know with a strange avatar who's coming up with very insightful points. Already, I'm a little bit skeptical about what's going on. Then if I found their name, I'd probably, message people that I know, Henry, have you heard of this person, Bob Smith, with a strange avatar? They seem to be so intelligent when it comes to this topic, etc., etc. So I think, human beings, we tend to be quite suspicious and quite vigilant. And that vigilance is partly at the psychological level in terms of, evaluating people's intentions and evaluating what lies behind their communication. But just as importantly, I think it happens at the sort of social, institutional level. And I think all of those things would be barriers to this sort of scenario unfolding. But also, once this sort of scenario unfolds, if there's a case where it does get detected, right, well, that's going to be the sort of thing that will generate enormous alarm bells and a big reaction straight away. So I'm very skeptical of the idea that these systems would be able to get their way in the world in a very specific and seemingly quite unlikely way, which is ultimately leading to the extinction of species via human influence and persuasion, because that's hard at the best of times, let alone if you're a purely, as it were, virtual system.
So interesting. Yeah. And this leads us on to some things we touched on last time, right? How hard is persuasion? So I think I completely agree with so many of your broader takes around misinformation and political influence. It's really hard. You can spend billions to barely nudge people's voting intentions. But just to give you another scenario, take some issue that you have. Give me just like an example of an issue that you have very strong views on.
Okay, let me think about this. An issue that I've got very strong views on.
All right, and let me pick one for you, right? That like the misinformation threat is overstated, right? Right. Just for example. Now, imagine the entirety of the CIA decided to devote its budget to changing your view on this, right? Don't you think they'd have a pretty high chance of success? It seems to me, they would have all sorts of actors in place to try and maybe, using all of their clever trickery, right? Get you inserted in intellectual circles with very smart people who give you clever arguments that might try and shift your dial a little bit. They'll pay for you to attend certain events or expose you to viewpoints that might challenge your presuppositions. Yeah. And, obviously you're a very scrupulous guy, so maybe this wouldn't work on you, but other people, financial incentives, right? Like, oh, we're paying you $25,000 to write an essay for us. Would you mind slightly softening this point, etc.? Maybe they'd try and sort of, if they're being really Machiavellian, try and alienate you from certain colleagues who would steer you back to the straight and narrow. Maybe they would, do all sorts of really dirty tricks, try and induce some mild psychosis potentially. I don't know. It seems this kind of so whilst I'm agree with you that like general purpose influence campaigns where you
Hmm.
try and shift the views of a populace or a large segment of a populace don't work very effectively. A sufficiently coordinated campaign to shift individuals, it's much less clear to me that can't work. And so to link this back just a little bit to our previous conversation, right? So you're saying, you'd be suspicious of someone who shows up with an anime avatar, but I think maybe, you don't start with the hardest nuts to crack. You start with the easier ones, right? So maybe they start with people who are less scrupulous than you. I would also say, by the way, like I don't think either of us know what Gwern looks like, right? And yet we both I'm sure, have quoted Gwern many times. Very few people know what Gwern looks like,
Right.
let alone his
Wasn't
real
there a
name.
podcast with Gwern, although it was a fake audio or something? Is that
Yeah, right, with
Yeah.
fake audio, exactly.
Yeah, okay.
So, I mean, I don't know. I think we live in a world in which anonymous individuals, the eminence grise, so to speak, of our eminence grise of our world, can exert quite a lot of influence.
Yeah.
So, anyway, sorry, I've just thrown about 7 different points at you. So.
No, that's fun. That's so interesting, and I think it opens up such a can of worms that, as we said previously, we should do an entire episode or even series of episodes on this. I mean, the misinformation example is funny because there I feel like there was a coordinated attempt by very smart, energetic, well resourced people to change my mind on that topic, and they weren't particularly successful. And that's for a kind of abstract, relatively recondite issue. It's not even the case that if I were to change my mind on that, it would be sort of antithetical to my self-interest. And I think to really get these sorts of, persuasion-based scenarios off the ground as something we should be really concerned with, then it's not about, a coordinated effort to change somebody's mind about an abstract intellectual issue, where it's already very, very challenging, but it's to change their mind in ways that are sort of contrary to their self-interest, where I think we've got so many more defenses that happen and that arise. But just because I'm sort of conscious of time, and I think this opens up such a can of worms that we should do another episode on it. Let's maybe just sort of end by shifting to the other issue, which is not just capabilities, but motivation. So you've already offered a really nice analysis of why you might be concerned that AI poses an existential risk. And I think it is worth saying, I mean, this is sort of obvious to us, but if there's anyone listening to this where they're not so immersed in the weeds of the X risk arguments, I think when people hear the idea that, super intelligent AI systems are likely to wipe out all of humanity, they think it's absurd because they think, well, why would an AI system want to do that? That seems like a very strange thing. And the argument is not that these systems are going to have as their ultimate objective wipe out all of humanity. The argument is rather, well, there are different ways in which the argument gets unpacked. One of them is to do with instrumental convergence that you very nicely elaborated on, where the idea there is, look, sort of irrespective of what the ultimate objective is, many sort of instrumental goals that a system that's hyper competent would pursue in the service of trying to achieve that ultimate objective, like acquiring more resources, getting more power, maintaining its own survival, ensuring that it doesn't get turned off, etc., would be antithetical to human interests. Potentially related to that, there are these arguments concerned with how difficult it is to get these quite inscrutable systems to be well aligned with the things that we want them to do. Let me throw out one reason why I'm skeptical, and I'll be interested in your response. And partly I'm interested in how you think it connects to those arguments and those worries, and partly I'm just interested in what your response is. I mean, here's a sort of glib thing sometimes people say about the AI risk debate. I mean, I heard this from Steven Pinker. I don't know whether he originated it, but it's something like, look, the existential risk scenario, invites us to imagine a system which is so capable, so super intelligent, it could wipe out all of humanity, at the same time as being so dim, so stupid, it doesn't understand that that's not what we want it to do. And I think if people give that argument, everyone gets very angry in the X-risk community because they think they haven't understood at all what's going on in this debate, right? But here's what strikes me as a sort of closely connected kind of concern. And here I'm slightly drawing on a recent article by Michael Humer. And it says, look, the power of these AI systems is ultimately rooted in a kind of generalization from training data, right? So what makes these systems so impressive, so capable, is that they're not just regurgitating the information that was in their training data. They're capable of extracting sort of broader, principles, strategies, bodies of knowledge, such that they can then be deployed far outside the distribution of those things that they were explicitly trained on. Right. Now, these state-of-the-art AI systems and presumably future iterations of them are trained, as you said, by sort of reinforcement learning, right? Where very, very roughly we're giving these systems examples of like good behavior, examples of bad behavior relative to our values. And on the basis of that, they're extracting kind of, broader strategies, bodies of knowledge, etc., so that they can then generalize beyond the specific training data. It seems to me the existential risk scenario is imagining systems which are so good at sort of generalizing based on their training data that they're super intelligent. We want to roll these systems out. They're incredibly effective, incredibly competent, incredibly successful agents, right? We want to closely integrate them into our society, our economy, and so on. They're these super generalization machines. And yet, even though we've explicitly trained them on examples of, good behavior, and there would be nothing within that category of good behavior which looks anything like wiping out all of humanity. And we've tried to discourage, what we deem to be bad behavior, where things like wiping out all of humanity would presumably be quite closely connected. So even though there's been that process of reinforcement learning, nevertheless, they somehow become misaligned in such a way that they end up extracting sort of underlying motivation, strategies, and principles, which are like almost completely diametrically opposed to the sorts of things that we were trying to reinforce. So I take it the argument there is not that, misalignment is impossible or even unlikely for the sorts of reasons that you've mentioned. It can be very difficult to get a kind of, precise targeting of the kinds of behaviors that we want. But rather that the existential risk scenario invites us to imagine a kind of misalignment, which would be a sort of comically extreme failure of generalization from the training data. What do you think?
Okay. Really interesting. Okay, so two responses. The first, I would say, if you notice, humanity is not, in fact, wiped out all lower life forms, so to speak, using lower in scare quotes, right? We haven't wiped out chimpanzees. We've wiped out some, quite a lot. We are in the middle of the sixth extinction and so forth. So I think that's because we can achieve our goals without doing so. So here's where I slightly perhaps depart from at least some of the framing of catastrophic risk scenarios, which is that I think probably in most misalignment scenarios don't necessarily involve total extinction of humanity. What I think the kind of core X risk we should be worried about, or civilizational level risk, is that we won't be running the show anymore.
Right.
And I think that is probably a stronger kind of claim, or I guess technically a weaker but more robust kind of claim for us to worry about. That as we build superintelligent systems, we're assuming capabilities here that are capable of massively influencing human behavior at scale, that they will decide what humanity gets up to next, right? Whether sort of deliberately, whether it's explicitly running the show, or just, as I say, acting behind the scenes as an eminence grise to advance what it thinks is in our interests, right? And as I say, what it thinks is in our interests, right? Even if it's been perfect, even if it's been very well aligned, right? It's still going to end up with a model of human thriving that may not be perfectly aligned. I mean, humans disagree about this all the time. So maybe it's the model of human thriving that has been taught to it by Elon Musk or by OpenAI or by the Chinese Communist Party or whoever it is, right? But that crucially, those actors are no longer actually in control of the system. Again, this follows pretty straightforwardly from sort of the idea of superintelligence. I mean, not 100% straightforwardly, but pretty straightforwardly. So yeah, it's this idea of sort of passing the wheel to AI that I think is a scary, is pretty scary in itself for a lot of people, even if it doesn't involve total extinction of humanity. The second point about sort of wiping out everyone, here's where I think actually the scenario that you said you are worried about, and that I think a lot of people are worried about who are more skeptical of X risk, misuse type worries. I think there are a lot of quite scary scenarios that sort of blur the line between loss of control and misuse, where someone unleashes on the world an AI that fits some narrow ideological agenda. Gives some silly examples. Maybe it's a degrowth institute, or maybe it's used by someone who has narrow political objectives, and then that system sort of escapes confinement. And we've seen similar things happen with computer viruses before, where narrowly targeted computer viruses, end up infecting far more systems than intended. So I think there's a whole catalog of scenarios, if we are sort of focusing on the ones where AI decides to wipe out everyone, where an initial human misuse case gives rise to a broader loss of control that causes catastrophic harms.
That's interesting. Yeah, yeah. And I think what that sort of showcases is, there are many possible scenarios here, and once you're dealing with systems with a suite of capabilities which are totally unlike anything we've encountered before, it's very difficult for us to straightforwardly forecast all of them. And for that reason, it makes sense to take this very, very seriously as a risk, this sort of combination of radical uncertainty with, awesome capabilities. I think another thing you said there, which is very interesting, is to do with this sort of loss of control. And actually that takes us back to what we started the conversation focusing on, which is to do with the speed with which AI systems transform society and the economy. Often in these sort of X-risk scenarios that people paint, you're dealing with quite a rapid transition from things seeming kind of okay to things going absolutely terribly. But just as you could imagine, as the AI as normal technology perspective argues, that the process by which these systems diffuse throughout the society and throughout the economy, you can imagine that being quite slow, but nevertheless utterly transformative. You could imagine the kind of risks and dangers similarly being quite, relatively slow. And there's this gradual displacement of control where it's never the case that, next Tuesday, we discover that everything's gone completely wrong for us. But over a course of a few decades, we transition from a society in which we're the ones ultimately calling the shots to one in which actually you've got these, basically alien kinds of systems which are in control, which probably would not be so good for human beings. Okay, that gives us
I'll
a
just
kind of...
say,
Go,
can I
go
just
for it,
say,
yeah.
I'll say, just to say quickly a point on that. There's a take that sometimes people sort of make fun of in X risk scenarios, but I think it's actually not a crazy take, which is that, capitalism is the real superintelligence, right? But
Right.
if we think about our lives as they are today, a large amount of influence is wielded by think tanks, by corporations, by various unelected governments. Of course, these are, in some sense, composed of people, but that doesn't mean that the interests of the corporation, of the think tank, are reducible to the interests of the people involved. I think it's pretty easy to imagine a scenario in which this kind of slow takeover scenario, in which AI tools, AI agents play an increasing role in our lives, increasingly start to influence politics according to their own priorities, increasingly start to influence our discourse. And we just sort of see the kind of, the nexus of control in human civilization ebbing away from us as individuals to these entirely non-human analogs of our sort of present day corporations and think tanks.
Yeah, that's so interesting. I mean, I do think but the main thing that comes to mind is just how much sort of uneasiness, suspicion, fear there is among human beings concerning state of the art AI systems right now. And I can imagine that sort of, building up and building up as these systems get more developed in ways that, honestly, if you're thinking about sort of, backlash to technological development, might create all sorts of issues and dangers on their own. But I am conscious of time. I think...
Sorry, just
final word.
one last thing. One last thing I'll say on this is just to emphasize again, right? I think AI influence is not going to come with a label saying AI influence. So just to give one fun fact, where we saw recently that the percentage of incidents of ChatGPT characteristic phrases in House of Commons speeches in the UK has been steadily increasing. So you can easily imagine AI systems wielding influence. If they assign a high likelihood that a query is coming from a significant policymaker, that ChatGPT has access to your entire chat history at this point. It knows who you are. To the again, this isn't something that happens with current capabilities, but it's not crazy to imagine that influence being wielded through humans who think they're in control, but are ultimately being nudged to align increasingly with the underlying goals of the AI system.
Yeah. Okay. Perfect. Well, I don't think we came to any firm conclusions about anything there, but hopefully that was an interesting conversation for people to listen to. Did you have any final comments, final thoughts, Henry, before we log off?
Yeah, I guess just one overarching thing that I think a lot of people sort of stumble with. I'm not saying you do at all, Dan, of course, but I think one just important thing to bear in mind in a lot of these debates is, if you grant that sort of these capabilities will be achieved, right? When you explore these scenarios, you have to remember that this stuff is by definition smarter than you. So a lot of the kind of classic sort of answers to superintelligence catastrophic risk scenarios involve, but then we could just do X, famously, we could just unplug it. whatever the kind of gotcha is. But of course, if we're dealing with a super intelligent system, it will have thought of this already, right? If we're dealing with a system that by definition has better capabilities at anticipating problems, at decision making, forecasting, planning, persuasion, and so forth, anything we can think of, it will have already anticipated. Now, I think that can quickly sort of become a sort of kind of circular argument where you say, oh, a system that is by definition better than us at everything, obviously nothing we could ever think of would ever be able to stop that happening. And I think, yeah, we shouldn't quite necessarily go all the way. That can lead to a certain kind of fatalism, perhaps, about superintelligence. And so, yes, we don't want to go the full way with that. But at the same time, you've got to remember that you're not dealing with a dumb system. You're dealing with a system that, but yeah, by definition is smarter than us in most respects. Maybe also worth noting, this seems a good point. One of the classic examples of this question, is there any instance in which an intelligent system is successfully made subservient to a less intelligent system? The classic example that people go to is parents and children, right? My daughter actually said to me the other day, she said, Daddy, why am I so good at getting you to do what I want? And she's right. She's very good. So, and I think this is maybe a kind of fun, useful, potentially useful heuristic for thinking about AI systems and or super intelligent AI systems and their capacity. And, there is at least one success case we've noted. But going back to our earlier point, or the point I emphasized earlier on, to the extent that we're worried about, not just us being wiped out, but us no longer calling the shots in our civilizational development, then maybe we don't take much. Maybe we shouldn't take too much solace from that example, right? At the end of the day, a child, even if a child has successfully entrained their parents to look after their interests, right? At the end of the day, if the parent has a psychotic break and decides that they no longer care about the child is screwed.
Yeah.
Or if the parent decides that, the parent converts to some radical new cult and believes that this, and acquires a whole new bunch of beliefs about what's in the child's interest, the child just has to, doesn't have any recourse. So, whilst I think that's a useful model for thinking about how we could get AIs that steer civilization in ways that look after us, right? We are still dealing with a loss of authority over the direction of our civilization.
Okay, great final thought. And I have so many things to say in response, but that means it's a great thing to end on because it can be an opportunity to pick up this conversation next time. So thanks everyone for listening, and we'll see you next time.